And between the routers I will use again the subnet, like between router 1 and router 3, 13 subnet. So see, actually I was configuring router 1. So the command to configure IP addresses on router number 1, you can see like this. I'm going to add command for all routers in this notepad, and after that directly I will paste on router. So you can see on fast ethernet 0/0 of router 1 fast ethernet 0/0 is connected with router number 3. So I'm going to use 13.1.1.3 here. And this is full mesh topology, right? See, between router 1, 2, 3, 4, I'm going to configure IBGP. I'm going to configure IBGP. Just a moment. This is my internal network. This is my internal network. So you can consider, like, we have you can say like 4 branch offices at different location: router 1, router 2, router 3, router 4. Even you can consider that this is a campus area network. You can consider like each routers at each building. Like I have 4 routers, so we have 4 building here in the campus. And for the redundancy we have multiple link, right? I have designed the full mesh. Getting my point what I'm saying? So this design is very common. Don't worry, I will explain the diagram here. And then we have 2 SP. This is not internet service provider, this is service provider only, right? Like this is my external network, this is my internal network. So between external and internal we have what? ISP, internet service provider. Just assume that the service provider is getting this subnet, right, from any other network. And now service provider is going to advertise prefixes to my internal network. So here in my internal network I am going to use IBGP. So let's suppose here ES number, BGP ES number is, ES is 100 on all the router, like router 1, 2, 3, 4. ES number 100 on these 4 routers. So router 1 will have how many neighbor? How many IBGP neighbor will have on router number 1? 4, correct guys? So let's say this is my autonomous system number 100, and the service provider is using different autonomous system number. Let's say the ISP1 is using ES number 100, ISP1, and ISP2 have different autonomous system number. Even we can configure the same, but as both are different ISP, so here I can configure different ES as well, right? But for now let's assume that in the service provider network we are running ES number 100. Got it? Now see the IP configuration on router number 1, right? On F0/0 13.1, on F1/0 1/0, and then I have one loopback here 1.1.1. See, I will use this loopback for BGP neighborship, like between router 1 and router 3 I need to form BGP neighborship. So guys, I will not use physical IP address. The benefit, we have multiple paths between router 1 and 3. This one, this one, this one, yes or no? Even this one. So multiple paths are there between router 1 and router 3. So what I will do, I will create one loopback here 1.1.1.1, here 3.3.3.3, and then I will form BGP neighborship with the help of these loopbacks. And after that, like let's suppose, see, the one scenario can be these routers are in the campus area network, in one large campus. right? At each building I have one router. And why we have multiple subnets? Like this can be department, right? Or let's say router 1 is the headquarter. Here you can see a headquarter router, right? And in the headquarter I have multiple departments. So for multiple departments we have multiple subnets. And BGP, why we are using BGP? Because of attributes. Here I have lots of options for the path manipulation. So according to our requirement we will influence the traffic. Let's say the first subnet is HR department, and my requirement is HR should reach in the external network in 50 network via ISP2, right? Or the sales department should reach to the external network via ISP1. And even that, in the internal network also I can manipulate the path. Like I can configure the scenario in such a way so that router 1 should forward traffic to router 3 directly, right, for the outside, or it should forward it to router number 2. Done. But first of all, let me do one thing. Let me configure the IP addresses. So you can see here, then I have loopback 10 to loopback 14. For these are the LAN subnets. So let me copy this command of R1 and let me create the IP addressing on router number 2 also. R2. Yeah. Recording is already started, bro. I know this can be new for someone, so right, that's why I have already started the recording. Just a minute. Just I am assigning IP addresses on the interface, and please keep checking if I am doing wrong. Is it correct? IP addresses on router number 3. Is it correct? No cert. Like if I am missing no cert command on any interface, please let me know. Here network is 1.1.1.0/30, and here network is, let's say, 2.2./30, like this. So IP 1.1.1.1 255.255.255.252. IP configuration on router number 3 is done. Let me copy the configuration and let me paste it on R4. I will share this IP configuration with you guys also. Like if you will design this lab, you can configure the IP. On F0/0, IP will be what? 24. 24.1.1.4 only. And huh. भेजू ना स्कैनर ठीक नहीं ठीक छे ना कोनो बात नहीं भेजे छे ठीक छे ठीक छे कोनो बात नहीं हम क्लास में छे भेज रहल छी कते भेजू से कहू ना हमरा कते भेजू से कहू ना कते भेजू ठीक छे ठीक छे Tell me guys, IP on F0/0, is it correct? Am I audible? Hello? Can anyone please confirm? Am I audible, Behzad? Okay. So IP is correct on F0/0, 24.1.1.4 correct. On F1/1 IP is going to be 14.1.1.4, and then on F1/0 IP will be 34.1.1.4, and on F2/0 2.2.2.2 2.2.2.1. So IP configuration on router 1, 2, 3, 4, and now let me do one thing. Let me configure the ISP router also. For that, I am going to take reference of R1 configuration, copy and paste ISP1 or SP1 on F0/0. Here, let's say the subnet is, what subnet you want to use over here. Okay. So on F0/0, which is going to be with ISP2, IP will be 3.3.3.1, and on F2/0, F2/0, IP over here will be 1.1.2. Subnet mask 252. Even we need to verify IP on this interface. R4, what was the slash value there? 2.2.1, correct. 2.2, 252, fine. Now this interface is not required here. This interface is not required. Here even loopback interface is not required. My God. Loop over here is done. Loopback one is not required. This loopback are required. Here, see, you can assume like these loopback, like ISP routers are receiving these subnets from any external network. 50 done. And in the same way, let me configure ISP2 as well. IP on ISP2. ISP2 fast Ethernet 0/0. IP will be 3.3.3.2/252. Here is the incorrect. Guys, please keep checking. Okay, then over here on F2/0 2.2.2, and on this loopback 60 60 60 60 and 60. Done. This is the IP configuration of all routers. Now before pasting the IP configuration, let me describe you this topology, like which type of company network will look like this. Okay, just 1 minute, then I am starting. Yeah, so let's talk about this design first. See guys, you can assume that this is my internal network. These router 1, 2, 3, 4, these are part of my network. This can be a campus area network, as I told you, and you can assume that these routers are nothing but a building, right? Like we have one router at each building. So there are 4 buildings in a campus, and see, we have multiple subnets on router number 1, on router number 2. So you can assume that these are different departments at each building, inside the each building. This can be one scenario. Then here in the building I have connectivity from SP from the service provider. Maybe I have another, branch, right, at different location. This is one university in Delhi, and they have one another branch in, let's say, Mumbai, in Bangalore, somewhere else. This can be one scenario. The second scenario can be, as I told you, you can assume that router 1, this is your headquarter, right, headquarter, and this one, router 2, is your branch 1, correct? So let's say again headquarter is in Delhi and in India, or branch office is in, let's say, in US, right, or in Canada, doesn't matter, or it can be in different city inside a country, like in India, Delhi and Bangalore, or Delhi and Mumbai. Okay, so let's suppose R1 is the headquarter router. This is my headquarter. This is branch office, and this is the data center. This is the data center, and in data center you can see my data center is connected with my external network through service provider. Now, can anyone tell me what is the benefit of using two routers here in the data center? Guys, for the redundancy, for the load balancing, like if I want to perform load balancing, for the traffic separation, like let's say I want to forward critical traffic in the external network via ISP1 and the normal traffic via ISP2, I can do, right? So I can configure the failover for the redundancy, I can configure the scenario to achieve load balancing, and even I can separate the traffic in the data center. And after that, you can see data center is connected with headquarter as well as branch office, and then I have connectivity from service provider for the external network, and these are my external network, let's say in different country. And again, see this side also we have same design like this. Like this side also, like ISP is connected with data center, and then you have headquarter and branch office, right? Like that. Scenario can be anything. The benefit of using multiple link here inside the internal network is redundancy, load sharing, traffic distribution, right? And the best benefit of using two edge router here in the data center is traffic distribution, like load balancing. In the same way, if you have multiple link inside the internal network, you can distribute the traffic, right? Let's say between headquarter and branch 1, headquarter is router 1, branch is router 2, right? So between headquarter and branch office, I want to distribute the traffic, right? Like if these all departments or these all buildings, now you can assume that router 1 is the headquarter router, and this router is connected with multiple different router, right? And from their neighbor they are running these subnets. So these are one building, like this is building 1, building 2, building 2, 3, 4, 5, right? So you have 5 buildings, and all buildings are connected together to router number 1. Okay, and here this is, let's say, this subnet. First subnet is sales department, second one is HR department, third one is admin department, right? Fourth one is finance department, like that. In the headquarter also, sales department, HR department, admin department, finance department. Now let's suppose HR traffics are the critical traffic, or in the data center I have one server, I'm hosting one application here on this server, right? The application can be, let's say, HR portal. We all are using it in the real time. So both headquarter as well as branch offices user should be able to access this server. Should HR people should be able to open the portal. So if you have multiple link between headquarter and branch office, what you can do, you can distribute the traffic, right? Again, here I have another server, right? And this time on this server I have, let's say, some application for the sales, right? Or for the finance. This is my finance server, right? Banking server. So all finance people should be able to access this server even from the external network. Here also we have HR, we have sales, we have admin, we have finance. So these finance people should be able to access this server, right? So we have multiple link. That means we have multiple option, right, to distribute the traffic, to achieve load balancing, to configure the redundancy, right? So if any link will goes down, no problem, still we can have connectivity, right? For separating the traffic. Now let's suppose I want that HR from the headquarter should access the application like portal via router number 2 by using this path, right? And the HR people from the branch office should access the server directly via router 2 to router 4, like that. And the finance people should access the server by using this link, right, via router number 3. I can configure, right, because you are running which protocol here, BGP, and you have lots of attributes, lots of options are there, right? In OSPF, in BGP we have very less options, but in case of BGP we have multiple attribute. As I told you, we have more than 12 attributes for the path manipulation. Getting my point? Is it clear, guys? Is topology clear to everyone? So here even you can see I have written some description as well about the router, like basic use case of this router. Scenario can be anything, right? This network is common design, like perfect for campus area network, for a large enterprises company, even for the medium sized corporate company, right? This can be a network of a bank, this can be a network of a, let's say, network support company, network solution company. This can be a network of what we say, the cloud security company who is providing, let's say, cloud security, right? So their external network is, let's say, nothing but the cloud application, right? These are the application on the cloud. And to access those applications from the headquarter and branch office, see how many paths you have. And as you have EGP protocol like BGP, right, you can configure the scenario according to your requirement, right? So let's say this one is multi building, right? Multiple building are there, or multiple branches are there, headquarter, branch office, data center. And this one, this area is nothing but the centralized data center, or you can say main routing hub, where I am going to distribute the traffic. If I will have only one router here, guys, in the data center, what will happen? All the headquarter users or the subnets and branch users will go outside via this router only, right? So that means there is only one exit point, and one entering point, right? Means outside user can enter in my network, in my internal network, via this router only, and any user from my internal network can go outside to the external network via this router only. But if I have multiple router, even I can configure the scenario like all traffic from my internal network to external network should go via router number 3, and all traffic from external network to internal network should come via router number 4, to distribute the load, guys. Let's say you are a network engineer and you have got a complaint that users are getting slowness, right? And the primary path is router number 3. So you have start monitoring the device, right? You have started the troubleshooting, and then you realize that CPU utilization of this device is getting high. Earlier your scenario was failover, right? Like one was primary, another one was secondary, and now you are realizing that this router is getting high CPU utilization, right? CPU utilization on this router is getting high, this router is getting hit. So what you can do, simply you can modify the configuration, some configuration only, and you can distribute the traffic. You can divide 50% traffic on router number 3 and 50% traffic on router number 4. Getting my point? Or let's suppose now in the current scenario everything is working fine, but after 1 year company have added some more subnets here, right? The company grown, they have added lots of devices here in the headquarter. So because of that, this router 3 or router 4 is not able to handle per unit amount of traffic. So again, you can you can modify the configuration. Even if you know how to configure this scenario, you can add one more router here, R5 as well, right? So try to understand the configuration, guys, very carefully. It is very important, and this one is completely real-time scenario. Got it? Now, to configure IBGP here in the internal network, see how complicated it is. Like, guys, on router number 1, first of all, I'm going to run router EIGRP, sorry, not EIGRP, BGP S number 100, then neighbor 2.2.2.2, remote AS 100, neighbor 2.2.2.2, update source back 1, neighbor 2.2.2.2, let's say password Cisco 123, and you need to apply these 3 commands with all other neighbor as well, like 4.4.4, 2.2.2, right? So to overcome this issue, to overcome this headache of network engineer, we come up with a new concept in BGP, that is BGP neighbor peer group. Neighbor BGP neighbor peer group. Now guys, let me ask you one question, then I will start the configuration of this scenario. See, the question is very simple. 3 routers are there, router 1, router 3, router 2 and router 3. 1, 2 and 3. And this is, these routers are in same autonomous system, right? In same autonomous system number, let's say on all routers you are running ES number 100. So in this scenario, can router 1 communicate with router 3? R1, R2 and R3, right? And the autonomous system number is 100. All routers are in same ES number 100. Here I have one LAN on router number 1, where I'm running subnet, let's say 10.1.1.0/24. And on router number 3, I have one LAN where I am running subnet 30.1.1.0. So tell me, this is a question, right? Can 10.1.1 ping to 30.1.1.1? No? Yes. Why no? Because of, guys, loop avoidance. Because of loop avoidance mechanism. First of all, see, R1 will advertise 10 subnets to R2, but R2 will not advertise that to R3. In the same way, R3 will advertise 30 subnet to R2, but R2 will not advertise that to R1. This is rule for IBGP. So what option you have to make communication possible between 10 and 30? What you will do in this scenario? What is the option, guys? Route reflector? Yes, route reflector, right? I can tell to router number 2 that brother, your neighbor, let's say router 1 is client, or I can say your neighbor router 3 is client. But let's suppose I don't want to configure route reflector here. Then is there any option available according to you? Tell me, just think and then tell me, because option is available still there, right? We can even make reachability between 10 and 30 without configuring the route reflector, and you all know that how I can do that. Not MPLS is not, see, MPLS is different thing. Like here MPLS is not required, brother. Don't worry about the MPLS. See, now you have one BGP neighborship here, one BGP neighborship over here. Fine, correct? In this scenario, what is happening? In this scenario, what is happening? Router 1 is advertising 10 subnets to their IBGP neighbor. So router 2 is not advertising that to their IBGP neighbor. So can I form one more neighborship between router 1 and router 3? Yes, right? Like to advertise this prefix to router number 2, I can form one BGP neighborship here. And to advertise this prefix to router number 3, directly I will form one BGP neighborship. From the router number 3, I am going to form neighborship here and directly router number 3. Correct? This is the option, right? Now in this scenario, router 1 is going to advertise TAN network to their both neighbor. Now router 1 have two neighbor, router 2 as well as router 3. But tell me how many command you need to run on router number 1. Tell me the command, number of commands. What commands you will run? First command, router EAGRP, BGP, router BGP S number 100, then neighbor 2.2.2.2 and remote ES 100, then tell me all commands for neighbor 2 first, like router for router 2 first. Next command will be router 2.2.2.2 update source loopback 1, loopback 1, right? If I want to configure the password, I will run neighbor 2.2.2.2 and password Cisco 123, and I need to run these all command for other neighbor for 3.3.3 also. Correct? I need to run these all command on router number 2 also, on router number 3 also. Minimum 6 command is required, right? That means 18 command. Like now guys, tell me in this scenario how many commands are required. It's very complicated, right, to configure full mesh IBGP neighborship, right? So that's why to overcome, yeah, sorry, yes. So to avoid this, we come up with this concept, neighbor peer group. See, in neighbor peer group, what you can do, you can create a peer group. I can say router BGP S number 100 and then neighbor, and I'm going to give name to this neighbor, any name, neighbor, let's say Cisco, and then peer group. Now whatever command you need to apply for neighbor, you can assign those commands here in this group, right? Now I can say neighbor and Cisco remote AS 100, then I can say neighbor Cisco and update source loopback 1. I can say neighbor Cisco password Cisco 123. If you want to add any more commands, like for neighbor I want to apply the route map, right? I want to configure the local preference and attributes, you can add those commands as well. Like if you want to apply that command for all IBGP neighbor, and now simply I can apply these all command to the neighbor. Like see, if I want to apply these all command for 2.2.2 for router number 2, simply I can say router on router number 1, router BGP S number 100 and then neighbor 2.2.2.2 and peer group, and the name of peer group is Cisco. Automatically it will apply these all 3 commands to 2.2.2. So like this I am going to configure IBGP here in this scenario. Fine guys, before that let me configure IP addresses here, R1, R2, let me access all device, R3, R4, and leave ISP for a moment. Done. On router number 1, let me copy the IP configuration command, and don't worry, you will have these commands, so you can directly copy and paste on your router. Copy and config T, and let me paste it over here. Fine. Let me save the configuration. Right. Now R2. Let me copy all commands of router 2. And by the way, we should verify the configuration once. I am directly pasting. In real time, you will verify the configuration multiple times. After that, you are going to paste on router. By the way, nowadays we are writing a script to configure the routers. Then router 3, copy and config T, then router 4, then router ISP1, let's say. Let me configure ISP as well. I will leave it. ISP1, ISP2. ISP1, then ISP2. Finally, last. Copy and paste. Done, guys. Now we can save the configuration. Right. I've already saved the R1 configuration. R2 right, R3 right, R4 right, ISP1 right. Done. Now what we can do, we can verify the connectivity like between routers. Like from router number 1, I can ping to router 3, 13.1.1.3, and the ping is working, right? I can ping to 12.1.1.2 to router number 2. It will work. Done. I can ping to router 4, 14.1.1.4. Ping is working. But can I ping from loopback to loopback? Like on router number 1, I have one loopback. That is 1.1.1. And this loopback is for BGP neighborship, correct? I have created these loopback for BGP neighborship to configure the BGP. Now can 1.1.1 ping to 3.3.3 or 2.2.2? No. So I need to configure any IGP protocol now here. Let me delete this lab is okay. Leave. I need to configure any IGP protocol to make reachability between loopback. See, I am not going to advertise this subnet in IGP. The reason, this router cannot handle BGP prefixes, because through BGP I am going to advertise lakhs of prefixes, thousands of prefixes, right? Even guys, it is not sure that in real time you will have BGP neighborship between all routers, right? Like between router number 1 and router number 3. It can be possible that directly we have neighborship between router 1 to ISP, right? Like my BGP topology can be like this also. Router 1 connected with router 2, or maybe not connected with router 2. Router 2 directly it is connected with ISP 1. Router 2 is connected with ISP 2. This is what BGP topology, because you know in BGP we can form indirectly connected neighborship as well, indirect neighborship as well, correct? So this can be a BGP topology, right? Or let's say this is your router number 5, this is your router number 6, and then here I have ISP1, SP1. This router is connected with ISP2. This is also real-time scenario. So in this type of scenario, generally your BGP neighbor, your BGP topology will be like this: router 1, router 2, router 5, router 6, and then ISP. Right? Definitely you will have BGP neighborship here, and here between router 1 to router 5 directly you will have BGP neighborship. Right? Here you will have BGP neighborship. Here you will have BGP neighborship. Here you will have BGP neighborship. This is what? BGP topology, logical topology over this physical topology. Getting my point, guys? So see, between router 1 and router 5, right, we have BGP neighborship, and how many paths are there? How many paths are there? 2, 3, 4, 5, 6. Yes or no? This is the benefit, right, of using multiple devices here for the traffic distribution, for the traffic separation. As we have multiple paths between router 1 and router 5, we can distribute the traffic, right? And like these routers are normal router, cannot handle lakhs of prefixes, so will not involve these routers in BGP. Now let me do one thing. Let me configure any IGP protocol here for reachability between loopbacks for the BGP configuration. So on router number 1, I am going to configure router OSPF. Let's say, which IGP routing protocol you want to use? Tell me anyone, any IGP, OSPF or any other. OSPF is fine, definitely, because in real time also most of the time we are using OSPF only, right? Router ID, even we can ignore the router ID because automatic router is going to select 1.1.1 as a router ID, right? Now here I can either run network command, but I cannot run network 0.0.0 command. Otherwise what will happen? It will advertise my LAN subnet in OSPF. But I want to enable OSPF on these physical interfaces, and this loopback interface 1.1.1. That's it. Right, guys? Because in the internal network we have lots of path. Okay, so here you can say router ID and 1.1.1. You can ignore it as well. Then you can say interface range F0/0, F1/1, F1/0, and F1/1. Okay, loopback 1, and then IP OSPF network type, network point to point, then IP OSPF process ID 1, area 0. This is the configuration, right? OSPF configuration. Let me copy it and let me paste it on router number 1. Done, guys. So IP OSPF interface brief, you can see OSPF is enabled. So IP OSPF interface F0/0 include network. Network type is point to point. And in the same way, I only need to change router ID on router number 2. Rest all configuration is going to be same of OSPF, right? So let me copy these commands and let me paste it on router number 2. Because let me verify the interfaces. Yeah, same interfaces are there. Done. So IP OSPF interface brief. And now I am expecting OSPF neighborship between router 1 and router 2. So IP OSPF neighbor. Got it? Done. And now ping 1.1.1.1 and source 2.2.2. So can we configure now BGP neighborship here? Yes. Between headquarter and branch office, now I can configure the BGP to exchange these LAN prefixes, right? These are 20, not 10. Let me correct it. On router number 3, router ID is going to be 3.3.3. Rest interfaces are exactly same. Copy and paste. Done. On router number 4, let me change the router ID only. Earlier I was planning to configure this topology like I was planning to come in class with the configured topology, but then I thought let me configure everything in front of you. Done. Yeah, welcome. Now I have enabled OSPF, guys. On router number 1 you can verify so IP OSPF neighbor, so IP OSPF neighbor. So router 1 have 3 neighbor, 3.3.3, 4.4.4 and 2.2.2. On router number 2, so IP OSPF neighbor. Here also you can see we have 3 neighbor. On router number 3, so IP OSPF neighbor, so IP OSPF neighbor. On router number 4, so IP OSPF neighbor. These are the basic configuration. Anyone have any confusion, any sort of confusion till here, any doubt? I have only made the reachability now between the loopbacks. That's it. Now, as I told you, I'm going to configure eBGP full mesh here, full mesh topology. So what I will do, see on router number 1, I'm going to create one peer group, router BGP S number 100, and then neighbor is name is Cisco and say peer group. And for this peer group, I am going to say neighbor Cisco update source loopback 1, then neighbor Cisco, and before that neighbor remote AS, neighbor Cisco remote AS 100, then neighbor Cisco, and let's say password Cisco 123. And after that, see, first of all let me verify the configuration if everything is correct or not. On router number 1, let me paste it. Done. All commands are correct. Now I need to apply this neighbor with all neighbors. So what I am going to say, neighbor 2.2.2.2, and then guys peer group and name of peer group, that is Cisco. Let me copy it and let me try to paste it on router number 1 and see, right? So I need to add this command for all other neighbor like 4, 3.3.3, 4, 4.4.4. and see how easy now it is to configure BGP here. Done, guys. So this is the complete configuration on router number 1. Copy and let me paste over here. What happened? Why I'm getting okay? See, all commands are correct. On router number 2, do I need to change anything? Yes. Neighbor instead of 2.2.2, here neighbor is 1.1.1. Router 1 have 1.1.1 neighbor, 3.3.3 and 4.4.4. Copy, and I think on router number 1 also I did some mistake. .4.4.4 is not there, right? So router BGP S number 100 and neighbor 4.4.4.4 Cisco and peer. What happened? Done. This is the command for router 2. Copy and let me paste on router 2. Now after running this command on router number 2, I am expecting BGP neighborship between router 1 and router 2. So IP BGP summary. All neighbors are idle. We should have, yes, now you can see with 1.1.1 we have neighborship. Correct guys? There is no any issue. Then for on router number 3, neighbor will be 1.1.1 and 2.2.2 and 4.4.4. Copy and let me paste it on router number 3. It's easy or not guys? On router number 4, instead of 4.4.4, I am going to say 3.3.3. Is it easy? Yeah, definitely. What happened here? Can't configure the local system as neighbor on router number 4. What I did 3.3.3, 2.2.2 and 1.1.1. Do so IP interface brief. Here the IP address is incorrect on loopback 1 interface. Interface loopback 1 IP address 4.4.4.4 255.255.255.255 on router number 3. So IP interface brief correct. See the issue here is 1.1.1. Okay, no problem. Where is the issue now? On router number 4 I'm getting the notification message. No router BGP yes number 100. I have removed the BGP from router 4. Let me troubleshoot the issue guys on router number 1. So IP BGP summary. So 3.3.3 is active. So there is some issue with 1.1.1 and 3.3.3 on router number 3. So IP route for 1.1.1 1.1.1 is directly connected on 2/0. So let me do one thing. Let me change the network over here. Let me say it's 6.6.6. Here I am going to say 7.7.7.1 7.2.2.2. So on R3 interface F2/0, let me change the IP address 6.1.1.1 255.255.255.252. So IP BGP summary. Now with 2.2.2 fine, with 4.4.4 is idle, and what with 1.1.1 do so run section BGP. There was some misconfiguration with IP address, right? Neighbor 2.2.2 4.4.4. Let me apply the neighbor group peer group with 1.1.1 router BGP S number 100 and neighbor 1.1.1.1 Cisco peer this command. On router number 4, ping 4.4.4.4, ping 4.4.4, and source 3.3.3.3. Done. Now on router number 4, neighbor 1.1.3.3.3.2.2.2. Correct. Let me copy it and let me paste it over here on R2. Now again on R1, so IP BGP summary. So with 2.2.2 and 3.3.3, see neighborship is fine, right? Soon you will get log message. Yes, you can see the log message now. Done. So IP BGP summary, we have neighborship with all routers on router number 2 also. So IP BGP summary, and on router number 3 also. So IP BGP summary, and on router number 4, so IP BGP summary. Done guys? Clear? Cleared? Any question? No. Now I have formed the IBGP neighborship in the internal network. Okay, one topic is still there, that is BGP states. Let me do one thing, let me discuss that also here. BGP states. So guys, we have 6 states in BGP. Number 1 is idle, and most of the time you have seen the idle state in our configuration. Second state is connect. Third state is active. Fourth state is, these are the neighborship state like OSPF, neighborship state, down, two-way, those things. Okay. The next one is, fourth one is open connect, sorry, open conform, open send. The fifth one is open confirm. And the last one, sixth one is established. These are BGP neighborship states. What do you mean by idle? Is there anyone who can explain the meaning of idle state? See, in the idle state, yeah, please speak. Idle means a router is waiting to start the BGP process. Connect state means when you will enable BGP on an interface, first state will be idle. It is similar like down state in OSPF. Connect. In the connect state, actually router will try to establish a TCP connection, right? It will send the SYN message. Once neighborship will come in, over here in the idle state, BGP will start the process. Then it will move to the connect state. In the connect state, it will try to establish TCP connection. Means it will send the SYN message. Yes or no? Router tries to establish a TCP connection. And now guys, try to understand, it is very important. If router is able to establish a TCP connection, then a state will directly move to open send, and it will send the open message, right? If router is able to establish a TCP connection, then a state will directly move to open send, and in this state router will send open message, the first message of BGP. If router is not able to establish a TCP connection, then state will move to active state, and again in the active state router will retry to establish a TCP connection. So most of the time you have seen that if router is not able to establish a TCP connection, state is showing active. Active means there is some issue with TCP connection. Okay, so connect state can move in active state either, or it can move in open send message, open send state. In the open send state, BGP router will send the open message. It will send the BGP open message. Then their neighbor router will generate the response, right? So once it will receive the response, state will move to open confirm, and once state it will receive the response from the neighbor, that is open confirm message. Once open message will confirmed, neighborship will be established, right? So very basic. Even video is available on my channel, you can watch. I think duration of that video is 10 minutes. So now you can see here these all neighbors are established. In which state? In established state. Clear, guys? Clear? Now on router number 3, so IP interface brief. On F2/0, which is connected with ISP1, IP address is 6.1. On ISP1 also I need to correct the IP config T interface F2/0 and say IP address 6.1.1.2 255.255.255.252. So IP interface brief. Now I am going to form eBGP neighborship. eBGP neighborship, and on router number 4 also I need to correct the IP. On interface F2/0, IP address is going to be IP 7.2.2.1 255.255.255.252, and then on ISP2 interface F2/0, say IP address 7.2.2.2 255.255.255.252. Now let me configure eBGP neighborship here between router 3 and ISP1, as well as between router 4 and ISP2. So router BGP AS number 100 and the neighbor 6.1.1.2 and remote AS 100. Correct? Any other command here I need to run, guys? Any other command is required? Is any other command required here? No. Not required. So let me take you to ISP1 router, and on ISP1 router let me configure the BGP AS number 100, not 100 here. Neighbor remote AS should be here. I can configure 200 like that, different AS 200. So let me correct it, guys. Here I am going to remove this command, say no to this, and the neighbor 6.1.1.2 remote AS is, let's say, 200. Done. Now on router number ISP1 router, right? Router BGP AS number 200 and the neighbor 6.1.1.1 and remote AS is 100. Now I am expecting BGP neighborship between router 3 and ISP1 router. Right, guys? So BGP summary, neighbor is active. That means there is some issue with TCP. So TCP brief. You can see there is no TCP connection, right? How to troubleshoot? First of all, we should ping the neighbor IP address. Ping is not working. What is the issue? Let me verify the IP. So IP interface brief. IP on F2/0 is this one. Line protocol is up, their status is also up. On the ISP1 router, so IP interface brief 6.1.1.2 line protocol is up, and the protocol is also up. Then why ping is not working, guys? What happened here? Six dot one dot one dot one, 6.1.1.2, correct. So run interface F2/0. Submit mask is 255.255.252 means /30 and on ISP1. So run interface F2/0. Yeah, IP submit mask is also correct. Why ping is not working? Debug IP ICMP and debug IP ICMP. How to troubleshoot? How to troubleshoot, guys? There's no ICMP traffic, so IP ARP. Even this ISP1 don't have MAC address of 6.1.1.1. Sorry, on ISP1. So IP ARP. MAC address of their own IP address. Incomplete. Can you troubleshoot? Is there anyone who can try? Interface F2/0 shutdown. Even their line protocol is up. So CDP neighbor ISP2 is on F0/0. Okay, ISP2 is on F0/0, that is correct, but there is no CDP neighborship as well even between ISP1 and router 1. What is the issue then? I think this is a problem of simulation software only, right? From let me try to ping from router 4 to ISP2. Ping 7.2.2.2. When here ping is working. ARP table. ARP is incomplete for 6.1.1.1. Definitely this can be issue of software then. So IP interface brief, because everything looks like fine. Oh, here IP address. See, I have configured this IP address on F2/0, right? I should configure it on F2/1. interface f2/0, say no IP address and shut down. Exit interface f2/1, no shut, and the IP address 6.1.1.2 255.255.255.252. Now ping 6.1.1.1, and now ping is working, and even we will have BGP neighborship on all. So IP BGP summary. Now you can see we have BGP neighborship here. Done, guys. Fine. Now let me do one thing. Let me advertise these external prefixes in BGP here on ISP1. Router BGP AS number 200 and network 50.1.1.0 mask 255.255.255.0. Then 50.1.2.0, 50.1.3.0, 50.1.4.0, and 50.1.5.0. 5.0. So IP BGP done. Now ISP1 is going to advertise these prefixes to router number 3. Am I right? So on router number 3, guys, on all, and so IP BGP summary, we have a BGP neighborship, you can see, with 6.2, and so IP BGP. Now tell me, will R3 advertise these prefixes to headquarter and branch office? Will R3 advertise these prefixes to their IBGP neighbor, to R1 or R2, or not? Hello? Definitely yes. Now the second question, if it will advertise, then will router 3 modify next hop? Will router 3 modify next hop? Whenever BGP router advertise prefixes to their IBGP neighbor, it does not modify the next hop. No, bro, no. Right? So you can verify on router number 1. So IP BGP. What is the issue? It is receiving these prefixes, external prefixes, but this is only valid, not best. So router 1 is not going to install it in their routing table. Second question, will router 3 advertise these prefixes to router number 4? Yes or no? Yes or no? Yes or no? Yes. Now, second question, will router 4 advertise that to router number 1 and router number 2? Yes or no? Yes or no? Definitely no. IBGP loop avoidance mechanism. Here yes, here no. Now if you want that router 4 should advertise, what you can do, you can configure route reflector. Before talking about the path manipulation, let me form BGP neighborship between router 4 and router ISP2 router, right? So let me take you to R4. Here on R4, I'm going to say router BGP AS number 100 and neighbor 7.2.2.2, and remote AS of this neighbor is remote AS of neighbor is 200. Then ISP2 and say router BGP AS number 200 and the neighbor 7.2.2.1, and remote AS is 100. Now I am expecting BGP neighborship here, and before that let me advertise 60 prefixes. 60.1.1.0 mask 255.255.255.0, 60.1.2.0, 60.1.3.0, 60.1.4.0, and 60.1.5.0. Now router ISP2 router is going to advertise it to router number 4, R4. So IP BGP, you can see 60.1.1.0. Soon it will receive REST prefixes as well. Yes, these are best as well as valid, but 50 prefixes are only valid, not best, because of next hop. Now I am going to advertise prefixes on router number 1 in BGP. So router BGP is number 100 and network 10.1.1.0, mask 255.255.255.0, 10.1.2.0, 10.1.3.0, 10.1.4.0 and 5.0. So IP BGP, you can see the BGP table. All 10 prefixes are self-advertised. Next hop is 0.0.0. All 50 prefixes are received by this next hop from router number 3, and these prefixes are received by from router number 4 with this next hop IP address. So these next hop IP addresses are not reachable. That's why router 1 is not going to install these prefixes in routing table. R2 config T, router BGP is number 100 and network 20.1.1.0, mask 255.255.255.0, 20.1.2.0, 20.1.3.0, 4.0 and 5.0. So IP BGP 60, 50, 20, 10, all prefixes are there. 10 and 20 are best. Now guys, path manipulation. Before that, let me do one thing. Let me save this configuration. This is the default configuration of BGP. R2, R3, R4, R5, ISP1 and ISP2. Default configuration. Now can the headquarter communicate with external network? No. Can headquarter and branch office communicate with each other? Headquarter and branch office? Can headquarter and branch offices user can communicate with each other, guys? Ping 20.1.1.1, source 10.1.1.1. Yes. Right? Trace route. Trace route 20.1.1.1 and source 10.1.1.1. Traffic is going via router 2 directly, right? Now tell me the IBGP path manipulation. I want to forward traffic from headquarter to branch office 1 via router number 4. What option you have? This is path manipulation in IBGP, so that's why I'm expecting answer from everyone. I want to forward traffic from headquarter to branch office via router number 4, guys. What happened? Hello? So IP route for all 20 prefixes. For all 20 prefixes, you can see next hop is 2.2.2. 2.2.2 and the router 1 is learning 2.2.2 through IGP protocol, through OSPF, right? So IP route OSPF, you can see 2.2.2 is there. Yes. When what next hop? 12.1.1.2 means IP address of router 2, right? But there are multiple paths to reach 2.2.2, right, guys? It can reach to 2.2.2 via router number 4 as well. But the cost over here, cost on this path is 2. 1 on this path, 1 on this path. Cost on this path is 1. So if I want to make this path as the best path, simply I can increase the cost over here, right? I can configure higher cost. Let me do one thing. Let me configure cost 5 here on this link. Interface F1/0 say IP OSPF cost 5. Now what will happen? So IP route OSPF. Now you can see 2.2.2. Just wait for some time. Yes, now 2.2.2 it have started performing load balancing, right? Because now cost is same on two path. Now cost is same on two path. One is this one, another one is this one, correct? So if you want to make this one as a best, you can increase one more cost over here. I can configure cost 2 here. Yes or no? This is path manipulation in OSPF, bro. Clear, guys? I'm not going to perform path. I'm not going to perform path manipulation in IGP, right? Let's understand path manipulation in case of EGP, BGP, right? But if you want to here perform path manipulation in the internal network, you can. But in OSPF, you know, you have very less options, right, for the path manipulation. And even these all routers are in single area, so you cannot summarize the route, we cannot filter the route here. Now again on router number 1 I am going to set default cost. This was just example, sorry. No, so IP route 2.2.2.2, still it is performing load balancing. Just wait for some time. Now you can see done. Now guys, to understand best path selection in BGP, you have to understand BGP attributes. So now topic is BGP attributes, very important topic, most important topic of BGP. BGP, or you can say best path selection in BGP, and this is your last topic, right? So today, maybe today we will finish the module. Today we are going to finish this module. Maybe this one is the last lecture. If I will cover all attributes today of BGP, then you only need to practice, right? So maybe this one is the last lecture, or tomorrow I can have a session for 2 hours. Done. So guys, first attribute that BGP is going to use for best path selection is next hop. Is next hop. Next hop. Try to understand the use of next hop attribute in this scenario. Right now, ISP1 is advertising 50 subnet. ISP2 is advertising 60 subnet. Now guys, if I will configure any IGP protocol between ISP1 and ISP2, or BGP protocol between these two ISP, because between ISP we are running BGP only, right? So what will happen then? Router ISP2 is also going to advertise 50 prefixes and 60 prefixes, and ISP1 is also going to advertise 50 prefixes as well as 60 prefixes. Am I right? Both will advertise these prefixes. But if I want to receive 50 and 60 both prefixes in the headquarter via router number 3 only, not via router number 4. So by default, next hop is not reachable. I can only make next hop reachable via router number 3. I will configure route map on router number 3 only, right? So this time router 1 will receive 50 prefix and 60 both prefixes via both neighbor, via router 3 also, via router number 4 also, but via router number 3 next hop is reachable, but via router number 4 next hop is not reachable, right? So which one will the best path, via router 4 or via router 5? Clear? Clear, guys? The another example can be router 1, router 2, 3, 4. These are my edge routers list. Let's say this is connected with ISP, this is also connected with ISP. Both ISP is advertising one X subnet. Here we will have eBGP neighborship, here we will have eBGP neighborship. Both ISP is advertising same subnet X subnet, right? So both router will advertise X subnet to router number 2. This is my internal network IBGP. So will these edge routers modify next hop? Answer is no, right? So I have to configure the route map here, or I can advertise the next hop IP address in BGP or in any IGP protocol which is running on the edge router to make next hop reachable from router number 2. So here I have control on the path with the help of next hop attribute. Yes or no? The second attribute, let's suppose here both next hop are reachable on router number 1 and on router number 2. For 50 and 60 prefixes, both next hop are reachable. On both sides, I have configured the route map. Then this attribute tie. So now it is going to check next attribute, that is wait attribute. Let me do one thing. Let me write down the all attributes first, then we will discuss all one by one. The third one is local preference value. Third attribute. Fourth attribute is ES path. Sixth attribute is origin code, I think. Yes, origin code. Origin code. I am writing these attributes in sequence only, right? Like BGP will always check these attributes in this sequence in descending order. First it will check next hop, then wait, then local preference, then ES path, then origin code. If origin code is also same, wait value is also same, local preference value is also same, ES path is also same, then it is going to check next attribute, the seventh one, that is metric. If metric is also same, the next attribute, that is eighth attribute, is external over internal. External over internal. External will be always before our internal. External, we can say over internal. If both neighbor are same, external or internal, then next attribute that BGP is going to use is IGP cost. IGP cost to reach next hop. If IGP cost to reach next hop is also same, then it is going to check oldest path. Oldest path. But you know, this attribute will check in case of eBGP only. This is only for eBGP. Only for eBGP. For iBGP, it is going to check what? Lower neighbor router ID. Router ID. But scenario can be like this: R1 connected with R2 with 2 link. So in this scenario, router ID will be also same, right? So if router ID is also same, then it is going to use next attribute, the 12th attribute, that is lower neighbor IP address. So these are your attributes in sequence. These are your attribute in sequence. Now guys, try to understand all attributes one by one. What happened here? Yes. So hope next hop is clear. Like next hop IP address should be reachable. Then only router will install that in routing table. Like example can be router 1, router 2, router 3 and router 4. Right here I have one subnet X. Here I am running BGPS number 100. So router 4 will advertise X network to router 3, router 2, router 3. Router, these routers are going to advertise to their other neighbor to router number 1 or not. By default not. But you will configure the route reflector, then definitely it will advertise. But it will not modify the next hop. So if you want to forward traffic in X network via router number 2 only, so you can modify the next hop on router number 2 only. If you want to forward traffic in X network via router number 3 only, you can modify the next hop on router number 3 only. This is the best example for next hop attribute. 1 minute. Clear guys? Is it clear? Now class is going to be very important, very interesting. The next attribute is wait attribute. Guys, let me write something about the wait attribute. Wait. WEIGHT. First thing is it is Cisco proprietary attribute. Cisco proprietary means you will only see this attribute on Cisco devices. Cisco devices. And BGP never carry wait information in update. In update, that means it is locally significant, means router is will never receive wait attribute from their neighbor, right? A BGP router will never send at wait attribute to their neighbor. Clear? It is locally significant. The third thing, next thing about that, the wait attribute is, you can say it is locally significant. And for self-advertised prefixes, prefix, by default, wait is 32768 by default. If you want to verify it, here I can show you. See the router 1 BGP table. So IP BGP. So IP BGP. See guys, for these are what received prefixes, right? These are received prefixes. And see, wait value is nothing for the received prefixes. But for the self-advertised prefixes, wait value is 32768. That means router is not going to share wait information to their neighbor. Wait value for received route will be 0 by default. Even not by default, you can configure, but BGP will not advertise it in the update. On router number 2 also you can verify. So IP BGP, you can see here 20 networks are self-advertised. So for 20, wait value is 32768. But for all received prefixes, doesn't matter it is received from the iBGP or eBGP, right? For all received prefixes, wait value is 0 by default. Done. Done. So you can see for received prefix, wait value is 0, and higher wait always preferred. Got it? Example can be R1 connected with 2 ISP router 1. Generally, you know why I'm giving example of ISP only, because most of the time in real time we are using BGP between our internal network and ISP only, right? Between service provider and internal network. So this is router 1 connected with two different ISP, ISP1, ISP2. Both ISPs advertising X subnet, right? So both will advertise with weight value what? 0 0. Now I want to prefer ISP1 over ISP2. Here I can configure higher weight value 10. Getting my point? By default, router 1 is receiving X prefix X subnet from both neighbor with weight value 0 and 0. If I want to prefer ISP1 over ISP2, I can configure higher weight value here. Got it? Then the next attribute is local preference. So again, let me write some basic points about local preference attribute. You can say local preference is most commonly used attribute in real time. Local preference. In short, we are saying LP. LP. So always keep in mind, BGP will always carry LP value, means local preference information in its outgoing traffic, but only for IBGP. Only for IBGP. BGP always carry local preference information for IBGP. For again eBGP, local preference value will be null. For example, router 2 is advertising 20 prefixes to router number 1. Which type of neighbor it is? IBGP. So it will advertise local preference value. Router 3 is advertising 50 prefixes to router number 1. Which type of neighbor it is? Again IBGP. So it will advertise local preference value. But ISP1 is advertising 50 prefixes to router number 3. What will be the local preference value there? Null. It will not advertise local preference value. So guys, on router number 3, so IP BGP. See the BGP table. For all 10 and 20 prefixes, this router is receiving all 10 and 20 prefixes from their IBGP neighbor. So local preference value is 100. This is the by default local preference value, right? But it is receiving 50 prefixes from their eBGP neighbor. So you can see for all 50 prefixes, local preference value is null, nothing, right? Again, it is receiving 60 prefixes from their IBGP neighbor. So local preference value is 100. Clear? Hope you guys have understand this. Okay. So what you can say, by default local preference value is 100 in outgoing update. Outgoing update, that means we are using this attribute for incoming traffic. Like guys, again same example, router 1 connected with two different ISP, ISP1 and ISP2, and this both ISP is connected with my data center. Let's say data center, and here on router number 1 I have some LAN. One is X. Getting my point? So router 1 is going to share this X network information to data center through this ISP. So router 1 will advertise X prefix to ISP1 also, ISP2 also. ISP will advertise it to data center. Fine. Now, suppose I want to receive traffic from data center via ISP1 only. I don't want to receive any traffic from data center to my internal network via ISP2. What I can do? By default, it is advertising with local preference value what? Hey, that is weight value, bro. Local preference. See, weight attribute is used for outgoing traffic, for the traffic which will go from inside to outside, from internal network to data center. And local preference value is used for incoming traffic, for inbound traffic, right? That's why I am applying for outgoing update. Like, bro, try to understand here in this example. This is what? External network. This is my internal network. Fine. I want to receive all traffic in my data center from this, sorry, from the in the headquarter, from the data center via router number 3, via, let's say, ISP1 only, right? Via ISP1 only. But both ISP, you are advertising, like router 1 is advertising it to both ISP. Your BGP scenario is like this. This one is the BGP neighborship. Router 1 have connection between ISP1 and between router 1 and ISP2. This is the BGP topology, right? And this is the data center. This is headquarter. So if I want to, you know, manipulate the path for incoming traffic, means the traffic which will come from the data center to which will enter in my internal network from the data center, for that what I have to do? I have to configure higher local preference value while advertising the prefixes. While I am advertising 10 prefix, right, I can set here local preference value, let's say 5. And while advertising 10 prefixes to ISP2, I can configure 10 prefixes. I can configure local preference value 10. What will happen? Yeah. Yes, for which type of traffic? For the incoming traffic, right? Like whenever ISP will check their routing table, whenever ISP will check their routing table, see, ISP here is one internet or data center. This data center, when data center router will check their routing table or their BGP table, there will be two paths, one via ISP1, one via ISP2. Here local preference value will be 5. Here local preference value will be, sorry, here local preference value will be 10. Here local preference value, yeah, 5 and 10, sorry, 5 and 10, right? Now it will install one in the routing table and it will use that route to forward the traffic, right? So which path it will install in the routing table, guys? Via ISP2 or via ISP1? Higher local preference is always preferred via ISP2, right? That means whenever data center router need to forward traffic in 10 network, it will forward to ISP2. That means I am influencing incoming traffic, right, with the help of local preference. Incoming traffic means the traffic which is coming in my network. The second attribute is weight attribute, right? So again, that BGP topology is this one, right? Now here I have configured weight value 10. Here I have configured weight value 5. So this time, whatever prefixes router 1 will receive, right, from the ISP1, it will set weight value 10 on this interface on 0/0, right, via ISP1, and whatever prefixes it will receive from ISP2, it will set at weight value 5, right? So again, in the BGP table on router number 1, it is receiving 50 prefixes from both ISP, ISP1, ISP2. From the ISP1, local so weight value is 10, right? For ISP2, weight value is 5. Which one it will install in routing table? 10, right? Means ISP1. So whenever router need to forward traffic to data center, it will forward to ISP1. So for which type of traffic I have configured the attribute? For the outgoing traffic, correct? For the traffic which will out from my internet network to data center. This is the very important, like you are influencing which type of traffic, outgoing traffic or for or incoming traffic, right? So LP is BGP attribute for inbound traffic. Weight is the attribute for outgoing traffic, outbound traffic. Clear? And by default LP is LP is 100. Okay, and again it is only for which neighbor? IBGP neighbor. Done. Now let's say I have a scenario like this, like router 1. In my scenario also you can see router 1 is connected with two ISP, two different ISP, ISP1 and ISP2. This is my BGP topology. I'm talking about this one, right? So here I am designing topology like this. Router 1 connected with two different ISP, right? This is similar like our example 1, 2, right? By default both are advertising same local preference value. By default weight value is also same, right? So these all attribute, next hop, weight, local preference, these all are same. Then it is going to check ES path. Now see that what is the ES path, guys. This is my router 1 and here is the data center, right? Data center, and this is headquarter HQ, correct? Now here I have connectivity from one ISP, Airtel. Here I have connectivity from another ISP, that is, let's say, Tata Communication. Here I have again connectivity from one ISP, Airtel, and then Tata Communication. But between these ISPs there are many more ISPs are there, right? Many more ISPs are there, correct guys? Right, and these all ISPs are connected like this, right? Let's suppose for example here autonomous system number is 100, here autonomous system number is 200, 300, 400, 500, 600, 700, 800, 900, 1000, 1100. Here AS number is 10, here AS number is again same 10. Both are part of my company. So R1 is advertising one subnet X subnet, right, to Airtel as well as Tata. Now Airtel is going to advertise it to other ISP, let's say this ISP. So will it include ES number? Yes, right, because it is advertising to the, yeah, correct. When router 1 will advertise to Airtel, it will include the ES, so the ES number will be 10. Here ES number will be 10 as well as 100, right? When this will advertise to this ISP, it will also include the ES number. Now let's suppose this ISP is directly advertising to this ISP, right? So it will include the ES number. So ES number is 10, then 100, and then 200. But this side directly Tata Communication is advertising to their other Tata. There is BGP neighborship, right? So router 1 will include their ES number, which is 10. Tata will include their ES number, that is 800. So 10 and 800 will be there, and then here 1000, right? So see, data center router is, guys, data center is receiving same prefix from both ISP, right? Airtel and Tata. Now it is going to compare number of autonomous system number that this route has crossed, and lower value will be always preferred. Lower value will be always preferred. Getting my point? See, in this scenario here also it is getting 3 number of ES. Here also it is getting what? 3 number of ES. But let's suppose here we have one more ISP. So it is there, we have one more ES number, that is, let's say, 500. So how many number of ESs are there in this update? 1, 2, 3, 4. How many number of ESs are there in this update? 3 only, right? That means upper one is the best path. Airtel is the best path. Right? Like this route from the Airtel is just crossing 3 number of ESs, but the route from the Tata Communication is crossing how many ESs? 4, right? So, and this one is also, ES path is also used for outbound traffic. So guys, both ISP1 and ISP2 is advertising one subnet X subnet to router number 1 with a S number, same AS number, let's say 10 and 10. But I want to prefer ISP1 over ISP2. What I can do, I can add one more ES here, right? I can add 20. Now automatically upper path means why ISP1 will become the best. Getting my point? Will show you practically as well. Then you have what next attribute? We can add the more ESs. We can add more ESs. Yeah. Correct. No, not extra router, extra ESs. Like, like let's say between router 3 and ISP1, there is one more ISP where autonomous system number is 600. So R1 will now prefer which path? Via router number, via ISP number 2. Because from this side it is getting only ES number 200. From this side it is getting ES number 200, which is ISP1 is advertising, and this ISP is 600, right? So two number of ESs are there. So ISP2 is the best. To reach in data center via ISP2, my traffic will only cross one ES. But to reach in data center from the headquarter via this ISP1, my traffic will cross two number of ESs. Clear? Clear, brother? Good, good, good. I think I have even, missed one attribute here. That should be self-advertise. After the local preference, you can add one more attribute, that is self-advertise. Like self-advertise prefix will be always before our received prefix, right? That is not important. Now the origin code. See guys, we have three origin code. One is I, the another one is E, and the third one is question mark. I for IBGP, not IBGP, IGP. See, how many of you know about the IGP protocol? Guys, earlier IGP was a protocol like your OSPF, BGP, EIGRP. Earlier IGP was a protocol. Nowadays we are not using it. So definitely we will be not using this origin code as well. No. IGP. See, in BGP, what will happen whenever you will advertise any prefix with the help of network command? See, we have multiple options to advertise network in BGP. So this was, earlier I had so told you like IGP as a protocol, and we are not using it. That's why we are not using this attribute. This is not the true, guys. By the way, this was the answer of one of my students. That's why I told you. This attribute means, this origin code means we have advertised network with the prefix with the help of network command. Like on router number 1, I have advertised the network in BGP. Network 10.1.1.0 mask 255.255.255.0, correct? Then origin code will be I. If you will redistribute prefixes in BGP, then origin code is going to be incomplete, question mark, redistribute, right? So this is redistributed route. This is network command routes, advertise routes by network commands. And this one is not in use, you can say. Earlier, not IGP, we had one EGP protocol. Which protocol? EGP protocol. Nowadays we are not using this, right? One from the same batch has said that earlier we had a IGP protocol. IGP, no, that is not IGP, that is EGP. EGP, right? So this is not in use nowadays. We have I and question mark. And now guys, which one is preferred? So always keep in mind, I is prefer over incomplete. I is prefer over incomplete. I means you can say the BGP dots. So what I am doing, what I'm going to give you one example here. What can be the example? Let's say R1 is connected with R2, connected with R3, right? Here I have 10.1.1.0/24, and here also I have 10.1.1.0/24. On daughter number 2, I have advertised 10 network in BGP with the help of this command network 10.1.1.0. On daughter number 3, I have redistributed this network in BGP, right? Redistributed. So router 1 will install which one in the routing table? Both are going to advertise to router 1, but router 1 will prefer router number 2. The reason? Origin code. Origin code over here will be what? I, and origin code over here will be what? Incomplete, question mark. Done. Then guys, we have what? MAT. MAT is exactly similar like matric in case of IGP, interior gateway protocol, right? So we will manipulate the path with the help of matric as well. Definitely we will have the session tomorrow, because now you can see the time. Okay, see, R1, R2 and R3. Here I have one subnet 10.1.1.0/24. Guys, this is my EAGRP domain. EAGRP domain, right? This is my BGP domain. So on daughter number 2, we need to redistribute EAGRP into BGP, correct? So if EAGRP is advertising route in BGP with matric, let's say 100, right? Then router 2 is going to advertise that route to router number 1 with same matric 100. But by default, for like BGP routes, router said here matric what guys? Null, 0. Got you? Now how you can use it for the path manipulation? R1, R2, R3. Here EAGRP, subnet, let's say X. So while redistributing, I can set matric here what? 10, and here I can set matric what? 20. So router 1 will receive X network from router number 2 with matric 10, and here with matric 20. Even I can add on router number 1 as well with the help of route map. Then external over internal, this is very easy. Like in this scenario, let's say this is IBGP and this is EBGP. So again, both IBGP neighbor and EBGP neighbor is advertising same prefix. Then router will prefer to which? EBGP. Yes. Okay. Then what you have? IP cost to reach next hop, like R1. Let's say R1 is learning 50 prefix from router number 3 also. It is learning from router number 2 also, like this, correct? So from this interface, what is the IGP cost? IGP is OSPF, means OSPF cost to reach next hop, 1 only. From this path, what is the cost to reach next hop? 1 plus 1 plus 1, 3, right? So which path is the best? If you want to make the lower path best, what you can do? You can increase the IGP cost here. I can say 10, like that, right? Or you can say router 1 will receive 50 subnets from router number 3 also, and from router number 4 also here, right? So how it is going to find the best path? With the help of IGP cost. IGP cost to reach next hop. R1 will not only receive these external prefixes from router number 3 only, right? It will receive from 4 also, from 2 also, from all their neighbor. Even all routers, router 2 will also receive all external prefixes from all neighbor. First of all, let me cover the all attributes. Now next attribute is IGP oldest path. So guys, if all attributes till here is same, IGP cost to reach next hop, then you can perform load balancing as well. Then you can perform load balancing. If all attributes till here are same, then only you can achieve load balancing in case of BGP. Otherwise, load balancing is not possible. Clear? For the load balancing, yeah, correct, bro. Done. After that, it is going to check what? Oldest path only for eBGP. Oldest path means a router 1 connected with router 2, router 3. Both are eBGP. Here AS number is 100, here AS number is 200, here AS number is 200. Both router are advertising X subnet, right? But let's say router 1 have received X subnet from router number 2 first. So it will install that in their routing table. Like oldest friend is the best friend, correct? That is using same concept. Oldest path will be the best path if all attributes till IGP cost to reach next hop is same. Because why? Because by default BGP cannot perform load balancing, right? So router have to have installed only one path in their routing table. It can not install two paths, right? So if all the attribute till here is same, then it is going to check what? Oldest path. Because BGP don't have capability to install two paths by default. Even all attributes are same then also, right? So it will check what? Oldest path for eBGP. What if these are iBGP neighbor? Then how it will perform the best path selection? It is going to check what? Lower neighbor router ID. So router ID of router 2 is, let's say, 2.2.2, and router ID of router 3 is 3.3.3.3. So which path will be the best? Router 2, right? But if router ID is also same, then it is going to check what? Lower neighbor IP address, which will be never same. Can it same, guys? Can neighbor IP address be same? Like two neighbor can have same IP? This is not possible, right? So here BGP is going to install one path. But keep in mind, as always, like BGP cannot perform load balancing. So now in this scenario, tell me, here we have BGP neighborship. How router 1 is going to select best path for 50 network? How router 1 is going to select best path for 50 network? See, it is receiving over here also, over here also, and over here also. Which one is the best? First of all, it will check what? First of all, next hop, reachability. So IP BGP. But for now, you know the reason why you are not able to see multiple path? Because router 3 is going to advertise 50 prefix to router number 4, but router 4 will not advertise it because of iBGP. So let me do one thing. Let me configure route reflector here. What I am going to do on router number 4, I'm going to say router BGP S number 100, and neighbor 3.3.3.3 route reflector client. What happened? Router invalid command. Actually, I have to add this command with here. So router BGP AS number 100 and neighbor. What was the name of peer group, guys? Cisco peer group. And here I am going to add that command, neighbor Cisco and route reflector client. Done. Now let me take you to R1 again. Now on router number 1, C, so IP BGP. For all 50 prefixes, 20 prefixes. For 20 prefixes, now it have installed 2 path. For 50 prefixes, still clear IP BGP star soft in. Even I can clear on router number 3, clear IP BGP star soft in. So IP BGP. Let me think. Just think, guys, why router 1 is not receiving 50 prefixes from router number 4. So IP BGP, it is receiving 50 from this. Okay, because next hop is not reachable. So router, even router 4 is not going to install it in their routing table. So let me do one thing. On router number 3, I'm going to modify the next hop address. How I can do? I can say route map, name of route map is CCNA or CCNP, and then permit sequence number, let's say 10, and here I am going to say set next IP next hop, let's say 3.3.3.3. Then again here we have peer group, so router BGP as number 100 and neighbor Cisco peer group, and I have to add that command here, neighbor Cisco and the route map, name of route map CCNP, and the direction. For which neighbor you are going to apply? For which neighbor? I am applying for Cisco, means for all the neighbor, right? So I will apply it for which direction? For odd direction, means whenever you will advertise prefixes. Now clear IP BGP star soft in, and go to router 4 now, and so IP BGP 50 prefixes are still clear IP BGP star soft in, and so IP BGP. Now 50 prefixes are, you can see, best as well as valid, because next hop IP is 3.3.3. Now let me take you to R1 and clear IP BGP star soft in for the faster update, and so IP BGP. Now guys, see 50 prefixes. Router 1 is receiving 50 prefixes from two sides, correct? From both sides, next hop is 3.3.3, but so IP route BGP. In the routing table, there is only one path. So can you tell me on the basis of which attribute now router 1 is selecting best path? On the basis of which? From the both neighbor, next hop is same 3.3.3. Next hop is same. From both neighbor, next hop is same 3.3.3. Then weight value is 0 from the both neighbor. Local preference value is 100. Self advertised, no, these are received route. Origin code is also CMCI. This is origin code. Then ES path is also same. Metric is also same. External or internal, both neighbor are internal. Then IGP cost to reach next hop. So IGP cost to reach next hop is IGP cost to reach next hop. So IP route 3.3.3. To reach this next hop, there is only one path available in the routing table. IGP cost to reach next hop 3.3.3. Okay, let's say IGP cost to reach next hop is also same from the both neighbor. Then guys, because IGP cost is for which type of neighbor? IGP is cost to reach next hop is for tell me. IGP cost to reach next hop attribute is applicable for which neighbor? For IBGP neighbor or EBGP neighbor? What about others? Why you guys are not speaking? Hmm? List cost. See, there are two paths, and in both paths, next hop is 3.3.3. And to reach 3.3.3, there is only one path. So that means IGP cost is also same. And then what next? Next attribute. Oldest path for EBGP neighbor, bro. This is IBGP neighbor. Oh, so IP neighbor ID or router ID? Let me do one thing. Even sorry guys, there is. Let me do one thing. For this prefix, I can ask you the question. Let me do one thing on router number 2. Router 2 will advertise it to router 4 because this is the client, this is the server, and non-client on router number 2. I am going to add what I can do here. For IBGP router reflector, I can configure that one. That is fine. That is fine. On router number 4, on R4. So IP route BGP and so IP BGP. So IP BGP 10 networks are there. Wait, router BGP S number 200 and neighbor 3.3.3.2. Remote AS is 200 and on ISP2 router BGP AS number 200 and neighbor 3.3.3.3 and remote AS is 200 on ISP1. So IP BGP clear IP BGP star soft in. So IP BGP. Now tell me, ISP1 is receiving 10 prefixes from router number 3 only. Why it is not receiving from router number 2 from ISP2? Why ISP1 is not receiving route from ISP2? Hmm? Because no. See, router 4 is advertising 10 subnets to ISP2. So ISP2 should advertise it to router 1. Sorry, ISP1. Definitely yes. But ISP1 will not accept it. The reason, they are on ES number. Like this, we can have loop. Like ISP1 is advertising 50 submit to router number 3. Then router 3 will advertise it to router 4. Router 4 will advertise to ISP2. ISP2 will receive. No, it will deny, because it will see their on ES number. This is loop avoidance mechanism, right? Correct. Now router 2 should advertise this 10 subnets to ISP. Sorry, ISP2 should advertise 10 subnet or not to ISP1. Router ISP2 should advertise 10 subnets to ISP1. Why? Same ES means, no, see, when router 4 will advertise 10 subnet to ISP2, it will include AS number 100. When a router advertise prefixes to their IBGP neighbor, it will not include AS number. So only AS number 100 will be there. Then why on ISP1 I'm not able to see 10 prefixes from ISP2? 10. I should learn ISP1 should learn 10 prefixes from ISP2 as well. Correct? Neighbor is, no bro, what I am saying that router 4 will advertise 10 subnets to ISP2, then ISP2 should advertise that to ISP1 na, right? So neighbor is idle, ping 3.3.3.1 on ISP1, 3.2 not working. So IP interface brief, IP is not configured there. Interface F0/0 no certain IP address 3.3.3.2. Guys, whatever question I have asked here, you need to verify those all. You need to verify those all. Yeah, now I am expecting BGP neighborship, so IP BGP summary, still neighborship is idle. So TCP brief, what happened now? So run section BGP. Here I have said router BGP 200 and the 3.3.2 remote AS 200, correct, on ISP2. So run section BGP. I have said 3.3.3. If this is one, this one is the incorrect configuration. BGP 200 and say no to this command first, and then say neighbor 3.3.3.1 and remote AS is 200. Now I am expecting neighborship, so IP BGP and summary. Yeah, now we have neighborship and see it have received 14 prefixes. Now on ISP1, so IP BGP. Now you can see it is receiving 10 prefixes from router number 3 also, from their eBGP neighbor as well as from their IBGP neighbor, right? From 77.2.2.1 means router 3 and 6.1.1.1. This is via ISP2. Why ISP2 is not modifying the next hop? Because it is advertising to the IBGP, right? So whatever next hop IP address router 4 have advertised to ISP, it is advertising prefixes with same next hop. But best path is via, guys, best path is via on ISP1. You can see best path is via now. Not ISP1, no bro, router 3. So how it is performing best path selection? Is this IP address reachable from ISP2? No, no, this IP. So this one is only valid, not best. Now let me do one thing. Let me configure one route for this IP address here on ISP2 just to make it reachable. IP route and F0/0. So IP BGP clear IP BGP star soft in. What happened here? Why this one is still oh, 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 oh. So IP route M7.2.2.1. Yeah, route is there in the routing table. Route is there in the routing table. Actually, ISP1 is performing best path selection, guys, on the basis of external over internal. Before that, what is the local preference value from this neighbor? What is the local preference value from this neighbor? So on the basis of local preference value, this path should be the best path, not this one, right? So guys, these are your questions. These are your questions from the BGP attributes. Why it is happening like this? Okay, just think, verify it, and then let's meet tomorrow again. I'm getting late now, so that's why please